Okay, so the 1/6 lesson continues with biconditionals and definition. So a biconditional is two conditionals that have been combined into a single statement. So the symbol for a biconditional is a double-headed arrow. Okay, so our P implies Q means it has to go this way, but a biconditional is going to be like this. P if and only if, or IFF, Q. So this is a much stronger statement, so both parts have to be true for the whole thing to be true. So really what P if and only if Q means is that P implies Q is true, and the converse, Q implies P, is true. So if you separate it out and they're both true, the biconditional is true. Or if you have a statement and its converse and they're both true, you can rewrite it as a single biconditional. So for example, if P is a prime number, then it has exactly two factors. So here's P, and here's my Q. That is a true statement. If I look at its converse, P has exactly two factors. If it's a prime number, there's my P. So this is Q implies P, and that's true. And this one was P implies Q. Since they are both true, I can combine them into a single statement that says P is a prime number if and only if it has exactly two factors. So rewrite. A quadrilateral is a polygon with four sides. So what are my two if-then statements? So if a figure is a quad, then it has four sides. That is a true statement. If I look at the converse, if a figure has four sides, then it is a quad, is also true. So what I can do is I can write those as a single statement that says a figure is a quad if and only if it has four sides. And all math definitions come from biconditionals. If I know a quadrilateral, I get four sides. If I know four sides, I get quadrilateral. It works forward and backward. That is only true in biconditionals. So now, for practice, let's look at how does our arguments apply to biconditionals. So, I have a little typo here. Direct arguments, this first part, check your notes, direct arguments work. Okay. So I can apply direct logic to a biconditional. I can apply indirect logic to a biconditional also. So if I look at an indirect argument, if P or Q is not true, then the other is not true. So if I had P implies P if and only if Q, let's say not Q, my conclusion would be not P. So given the premises below. So 258 is divisible by 6 if and only if 2 and 3 are both factors of 258. So this is a direct argument example, direct logic. So I've got P if and only if Q. Q happens, therefore P has to happen. The order doesn't matter with a biconditional and direct logic like it does with just a regular conditional. So my conclusion is, therefore, 258 is divisible by 6. Then let's look at a proof example. Given Q is the midpoint of PR and R is the midpoint of QS, prove that PR equals QS. So we put our given down. And then we mark our picture. So Q is the midpoint of this piece, and R is the midpoint of this piece. Okay, that gives me some information. I'm after QR or PR and QS. I'm after this piece being equal to that big piece. And that's interesting because they overlap right here. So in this case, what does the given give me? Well, midpoint gives me equal pieces. So I know that PQ is equal to QR, and I know that QR is equal to RS. And that is by definition of midpoint. So remember, if I go from words to an equation, it's a definition of the thing, whatever it is I'm doing. So now I see here, these are both equal to QR, so I'm going to say that PQ is equal to RS by substitution. That just seems like a natural step. Now, I've talked about getting PR and QS in the recipe. So let's write an equation for them. And whenever I have a picture, one of the equations I can always write is that parts to whole relationship. So I know that PR is equal to PQ plus QR, and I know that QS is equal to QR plus RS by parts to whole. Now here's that pattern. Once I have an equation, I want these two guys equal to each other. So can I do any substitutions to make that happen? Well, right here, I know that PQ and RS are the same thing. So why not replace here? And I'm going to write that PR is equal to RS plus QR by substitution. And now, if RS plus QR is the same as PR, and RS plus QR is the same as QS, I can replace this with that, and I can say that QS is equal to PR by substitution. Good luck with your homework.